Your use of the Death Star concerns me.
Aren't you a little short to be a stormtrooper?
Welcome to the show. I have with me today Dave Harrison. Dave is a senior consultant with Microsoft, and he's going to talk to us today about microservices. Dave, what's up, man?
Not much. I'm just hanging out here in Central Oregon, enjoying the beautiful weather.
Woohoo! So what's the weather like this time of year?
It's funny. In Central Oregon, it goes from being like full-on summer to like full-on winter in like 3 days. It's a very quick switch. So it's cold. The wind is going through. My goats are they're experiencing some pains right now with the quick switch. So
really? Wow,
yeah.
That's kind of neat. You've got goats.
Goats, chickens, and rabbits. My girls love them. So it's great living here on the farm. I really enjoy it.
That's awesome. So tell me a little bit about what a microservice is.
Well, a microservice is just a different way of looking at applications, especially when they become hard to maintain. We call them big balls of mud. It's a way of kind of partitioning your application so that it's safer and easier to basically maintain it and extend it. You're looking at, instead of the entire application, rolling it out each time with this massive rollout in a war room, very small size teams, maybe 6 to 12 people, and they're just looking at a particular aspect of the application, like authentication. There's a lot to be said about this model.
Okay. That sounds kind of neat. It sounds like the development teams are smaller. It's a little bit easier to manage.
Exactly. With applications, no one can know everything. But when you have those like 1 or 2 pizza-sized teams, like, and Amazon is famous for saying we won't have a team bigger than we could fill in a room and feed with 2 pizzas. So that when you have that size of a team, it's much easier to kind of get work done and roll out changes faster.
Awesome. And now I want pizza.
I know.
Okay. Well, I hear you have a presentation for us, so I'm not going to stand in your way.
So this is a presentation I put together on practical microservices. And there's more notes and a lot more material on my blog we can talk about later. But when it comes to microservices, many people are not entirely clear what they are. And that's understandable. It's a very new concept. And then, the other questions are, well, how can they help me? How can I benefit from this? And we typically see people fall into 2 camps. First off, microservices are a fad. The second camp is, this is good for everything and any company in any situation. And neither stance, we believe, is really balanced. So we're going to talk about some of the hidden traps and drawbacks behind microservices, some of the positive sides of it, and how you have a roadmap for your company. So yes, not just MC Hammer Pants. It actually is going to be something that will be here for many decades. Will it work for you and your company? Some pitfalls. And we're going to talk about 2 sample roadmaps. So it will give you some practical starting points when you're thinking about applying it to your company and your development teams. We will say this much, just to kind of sum up the presentation in advance. We believe microservices will be a difference maker for some companies, but not all of them. We also believe that Agile and DevOps will be a huge win for most companies, although there's kind of a limiting factor on that as well. And lastly, Docker and containerization, we believe that will be almost everywhere. So that's how we feel things will be out in the industry over the next 10 to 20 years with microservices. I will say this much. With Docker, we get very excited about it, and it is wonderful. Jim Gaffigan talked about how good bacon is. To improve food, you wrap them in bacon. And I feel that way about Docker as well, and containerization. It works very well, even with more traditional monolithic type applications. You have no more mismatched environments, no more, hey, it runs on my machine. If it runs on Docker, it will run on the servers in production where Docker is running. And it's as much of a philosophy and a process as it is a tool. And allows you to better use resources. So we do love Docker. We view it as being very much something in the future. The problem with Docker is that, and with microservices as well, is we tend to get the tool confused with the process. So for instance, with Agile, we thought, oh, Agile means source control, right? Well, that really was only a part of it. With DevOps, we thought, oh, that means release management, right? We can use software to solve this problem. And it's true that software is important. It's good, but that's not the only part of it. It's not even the most important part. We thought services-oriented architecture meant ESB. So the same thing is true with microservices and Docker. Again, it's not equivalent. It's really only a part of the puzzle. And we'll talk about this a little more in the future. As far as what are microservices, let's talk about how application development currently looks. This is a picture of a shanty town near Kingston. And the sad thing is, when I went to Jamaica back when I was about 16 years old, and today this place looks nearly as bad or even a little worse than it did back when I first went there. Everyone seems to agree that slums like this are a bad idea, but still they appear, and over time, it becomes permanent. When we look at a shanty town or a slum like this, it's clear it fits the needs. People need to have shelter, but the problem is they have little or no capital. Architecture is a luxury that many people can't afford. So this type of a sprawl, it requires little specialization. You can improvise. It requires a huge amount of improvisation, creativity, a broad range of skills. But the problem with this is that it's self-perpetuating. A slum like this, a shanty town, has very high maintenance costs, especially labor, and it's self-perpetuating. It's very hard to kind of introduce clean architecture in a place like this. So what we're looking at here obviously is a failure of government, policy, a forethought. We traded expediency, kind of a cheap investment, for a long-term nightmare in the form of high maintenance costs and constantly being stuck in survival mode. The problem is that many of us, with our application development, maybe without knowing it, we've found ourselves living in a structure like this that is sprawled out of control. And it's the same kind of causes. Unskilled labor. We don't have a lot of developers available, so we're just kind of patching this as we go. There's no specialization, very little thoughts about architecture. It ties down 3/4 maybe of the team and maintenance costs. Every sprint, it seems like we're excited, we can finally start working on new development, but then on day 2, there's a lot of bugs that pop up that need to be nailed down, or the rollout broke because there's no testing. And architecture we basically pay a very high price in supporting an application like this. It may be quick to build, requires a low cost, but it requires improvisation. It's hard to live with. And as an application developer, I found myself in that state many, many times. It's challenging. So again, development, and another thing that contributes to this is the fact that many times as an organization, we look at things as being a project. And when a project ends, the application gets orphaned. We don't consider it as a product, something that must absolutely be maintained. The other factor that kind of creates these things is that there are a very highly siloed organizational structure. So it leads to workarounds, shortcuts, tribal knowledge. The tools are pretty primitive. There's little thought about frameworks. These are the factors that kind of led ourselves to considering design solutions such as microservices. So as far as what the definition of microservices are, there's several out there. Some are very, very simple, and I like this. It says it's a software building block that does one thing and does it well. Sam Newman came up with another one, microservices being small, autonomous services that work together well. So my kids always enjoy that TV show, Big Hero 6. And in it, the hero, he creates like this great structure out of these little, almost Lego-like building blocks. And we could almost think about microservices as being that way. Tiny little components that added together can create very complex structures and be much easier to sustain. This is ideal for very big, hard to manage structures that have grown kind of beyond the boundaries set by the initial architects. Here we are really looking at replaceability over maintainability. We'll get into more on that. The longer definition that I really like comes from Martin Fowler. And he defined a microservice. I'll let you read it there on the screen. But it's a small component that is easily replaceable, independently developed, and independently deployable. So I know, for example, with my war room deployments I used to do, there'd be thousands and thousands of lines of change code. And it could be any one of a number of domains. And the rollouts were painful. They would stretch out across 2 or 3 days. And then post-rollout, inevitably we would have bugs. Because we didn't have strong testing, it was very hard to catch these. So you notice right here it says a goal of microservices architecture is to build a set of small applications that are each responsible for performing one function. Each microservice should be autonomous, independent, and self-contained. So this right here is very clean. It's easy to understand. I mean, who of us doesn't like doing one thing and one thing at a time? You know, then you really get a lot more competence around that area. The fact is, though, it is kind of a balance between safety and speed. It's definitely true that back in the mid-2000s, services-oriented architecture, or SOA, kind of lost its way a little bit because they tried fitting it to some products that were out there, and it featured, over time, it grew into something that was very heavyweight. It had centralized governance, a hub and spoke model. It was very, very cumbersome, and it actually made development harder. Some people are concerned that microservices will lose their way by going too far in the opposite direction. Where the team has complete autonomy, they're developing everything in complete chaos, governance is impossible, it becomes unworkable and unmanageable. Personally, I don't believe that vision will take place, but there is no doubt that if we do not plan for governance, it can actually create worse problems than it was meant to solve. So some of the benefits of microservices. First off, you have very strong module boundaries. Now, this, we talk about the shantytown or the bit of mud, like with that spaghetti you see right there in that picture on the left. And perhaps you work in an organization where your application has kind of grown into that state. I know I have. Putting modules into separate services makes the boundaries firm. It's much harder to use workarounds. Like, for instance, the database guys are all tied up and they're difficult to work with, so I'm going to stick my data logic here where it doesn't belong. Well, you really can't do that as easily when we're talking about microservices. Sam Newman mentioned one story, for example, where there was a project that was in trouble, and they had to dump a lot of developers into this project so that they could make their time deadline. Well, we all know what happens when you add developers into a project, a game, right? It actually extends the deadline. But because they use microservices, because they were thinking only of a part of the application, they could drop 8 or 12 developers into a team. And because they didn't have to master the entire application, it actually led them to ramp up much faster. So there's some very strong architectural reasons why microservices are a very good fit, particularly where your application has grown out of control. So again, Martin Fowler mentioned that in his view, in his judgment, microservices are significantly easier to maintain. Architecture must come first in planning when we're talking about microservices. So it enforces discipline, which is the exact opposite of what we see in many applications out there. It's also nice not being involved in that three-legged race. I remember many times I would be rolling out an application. I'd have to have 16 or more teams in the room, like representatives of them handling testing. And again, that extended our testing, our rollout to many days. It made things very difficult, like the three-legged race that you see right there in the picture. Having independent deployment is such a gift because it allows us to react very fast. If the rollout doesn't work, we'll know fairly soon. We can roll back very easy. And because we're only impacting one tiny part of the application, we know that it can be a lot safer. Our release bits are very small. And here's a very powerful point. I live in Portland, and development resources are very limited. It's oftentimes very hard to put together a team of 100 or 50 people in just one language, let's say C# or Java or Node.js. But because with microservices, you're using kind of an API construct there where all of your applications, your services can be treated as a small black box. an API layer, REST-based, in between. That black box can be written in anything. So, for example, if you find communication easier using Go or Erlang or Haskell, you can do that. You don't need to confine it to just one particular technology. So that makes it easier, I think, in hiring resources and kind of fitting the best tool for the job. I will say this, and this has been brought up in many books, just because you can use any technology underneath that service layer, it doesn't mean that you should. Keep it as simple as possible. Many companies have used a lot of governance around how they want their services to be written. There are other...
that's pretty cool.
Go ahead.
Sorry, I was just going to say that's pretty neat.
Yeah, it is, absolutely. And this is what services-oriented architecture was supposed to kind of fix, right? Having things be reusable and composable. Hey, our authentication layer isn't working, we can whack it and replace it with something else. It's much easier to fix code when you keep the scope kind of confined like that. The fact is, SOA didn't quite realize the benefits of reusability, but that's different with microservices. Here we're focused on speed, domain boundaries, disposable code. So it's easy to fail and move on. You can experiment. So, for instance, I live here in Central Oregon, and we have cows everywhere. And that's what we want. We want cattle, not pets, in other words, it's not irreplaceable. We don't have snowflake servers out there that are trying to do everything, and you can't touch them.
Right.
It's usually very single purpose.
Right. And by the way, I actually did have a cow that was a pet, so.
I did too growing up. They're wonderful animals.
Yeah, mine was named Dogie.
Dogie.
It got too big and started, you'd have to run from your car to the house because it would charge you because it thought it was playing, but it was, a 2-ton cow. Pretty funny.
Yeah. They have wonderful personalities. It's one thing I've learned. Living on a farm, I've kind of learned that is that the chickens and the goats and the cows have like the best personalities imaginable.
Yeah. So one thing that this reminds me of just watching your presentation is this is going to be old, right? This is going to definitely tell my age in the IT world. But I don't know if you remember when we moved from, just writing C code to kind of the modular programming methods that are popular now, right?
Right.
It seems like it's kind of that same model.
That's so true. I know, for instance, with the Visual Studio team, we weren't getting our releases out often enough. It was like every year, every 2 years, and we were falling behind big time. So they had to split teams up into 6 to 12 people. They had to co-locate. They had to make these organizational changes. And now they're doing releases multiple times a day. It wouldn't have been possible without microservices.
Yeah, that's pretty cool. All right, I'm going to let you continue.
Thanks, Lex. So the fact is, we know with some services, sometimes they require high availability but are low volume. Others are the exact opposite. So if we use microservices, we can tune them for either of these situations. But with a monolith, it's all or nothing. I've heard people say, even some organizations in the Portland area, hey, this monolithic code base that we had was so massive and so broad, no one knew all of it. People had their own areas of expertise, and they were kind of custodians around submodules, and they were craftsmen. And that became something that just wasn't supportable. What happens if you lose that craftsman, that guide to the shanty town? So it does offer, it's very flexible. You can use things like automation, feature flags. It's versionable at the API level. I like the idea, though, getting back to it's exactly what you brought out, Lex. It's about replaceability of components. We can bring down and bring up again one of these little sub-services, and it won't disrupt everything in the application. It's not as brittle as a monolithic code base. There's some business benefits to it as well. It allows us to run multiple initiatives in parallel, and it's agile. It ties in very well with the cloud. We can package this up for on-prem, or move it onto the cloud. Your choice of vendors. It's much easier, I guess, to comprehend. Increases accuracy. It simplifies our planning. much quicker ramp up for teams. These are also some benefits. The success stories that we have seen so far tend to favor companies like media companies. They're streaming. Think of Netflix, Amazon. They're streaming media in large amounts. So those companies value speed more than safety. If we're talking about a retail bank with strict regulatory compliance requirements, immediately you might have some concerns, and we'll get into that because it might not fit that scenario. So some hidden pitfalls. First off, there's distribution. Remote calls can be a lot slower than in-process function calls. So you can, and you probably will experience at times, some horrible latency issues. Now, this is fixable. You can do asynchrony, which is very typical for many companies out there. But you must factor reliability into your design. Again, Martin Fowler said, I'm always reluctant to play the distribution card. And I think too many people go distributed too quickly because they underestimate the problem. So latency, network latency is an issue you must factor for. I believe this is solvable, but you must kind of plan for it in your architecture. The other problem is eventual consistency. And this is why I say for many retail-based, I guess, banking type applications where transactional consistency is just critical. That's where microservices could perhaps be a mismatch. Because in this case, your business could be making decisions based on bad or partial information. Your information may be out of sync. This could be an issue. If you really rely upon very accurate near-time reliability, you might have some problems there. Now, monoliths can suffer from this as well, but usually consistency is a much easier target to hit when you have a monolith, for instance, versus a microservice. It's not that you can't make transactions work with microservices, but it is harder. Lastly and I think this is most important, is operational complexity. So this drawing right here is from Martin Fowler's website, and it shows how as the application becomes more complex, yes, microservices become a better fit. And definitely for less complex teams, there's the extra baggage required to manage microservices reduces your productivity. It's the exact opposite result that you want to have. But as you have a larger team that are very competent, yes, it becomes a good fit. So even someone like Susan Fowler, who's a proponent of this, who's used it before at Uber, she said ultimately you must come to terms with the fact that microservices are more expensive than other architectural styles. Debugging is extremely hard with this. Boundary and domain-driven design is not something a lot of developers know. So that complexity isn't eliminated when we move to microservices. It just moves it further up, and it makes isolating issues very, very difficult. So the services tend to get much simpler, and that's appealing to us, right? But the architecture of our applications gets much more complex. Now we can manage that with tooling, automation, and processes. Maybe that payoff is worth it for your organization, but maybe it isn't. And notice right there, the note at the very bottom, the skill of the team will outweigh any choice of your architecture. So you have to take a look at your team and say, are we really ready for this?
Yeah,
Just as an example, this is Netflix. They call this the Death Star. This is how their architecture layer looks on the services side. Imagine trying to troubleshoot this. Let's say that there's 1,000 or 10,000 microservices here. Very, very complex to maintain this. And here's the thing, your technical debt can build up very quietly in the background. Each of these teams is kind of making their own decisions, but the work is getting done. They're focusing on velocity, but it's not always best or the most optimal way. So for Netflix to create something like this architecture, this very complex, they had to put a lot of thought into how they want to have their services work and how they're going to deal with controlling technical debt. Because your developers can and will run away with new features, and eventually you'll end up maybe even in a worse state than you were before when you had a monolith, a single way of writing code. The other factor, of course, is trying to find the large number of people that you'll take to kind of manage microservices. We do see in the in the industry that bad code is driving out good code. Architects are, leave, and suddenly you have big balls of mud, guides to them that are indispensable. When you deal with a microservice deployment team, developers are usually on board with it initially. You hand them a pager or a cell phone that they have to maintain 24/7. And they realize the implication of this is I could get a call at 3 in the morning. With a microservice, you are responsible for the end life of that 24/7 support of that application. So that at that point, we start seeing a lot of resistance from developers. There's a reason why inertia has kind of ruled many of the applications we've seen. And we say, oh, we'll let operations handle it. That may not be healthy, but we have to take that into account. It is kind of a con that we are allowing our developers now to do end support alongside operations. This is a picture of the North Fork Nehalem River. It's a beautiful river that I love in Oregon. Now we're only looking at a few pieces here, but I think you can agree this is a very complex ecosystem. There's a lot going on here that is out of view, and it doesn't happen just overnight. The same thing, this kind of a robust, bulletproof ecosystem is going to be necessary for you if you decide to go down the whole route of microservices. It will require rapid provisioning of environments. You must do continuous delivery to have your rollouts happening fast. So when a developer checks in code, it makes it out to production as soon as possible in an automated way. There's not time for a lot of manual checks. It calls for culture change. We know that this is difficult for larger and older organizations. Now, when you try to make this change, a monolith can survive if you can't make that leap, but a microservice where suddenly there's a holdup on the development or database side or the QA side, they can't survive. It's too traumatic. So you really must have a very risk-friendly culture in your organization. The companies that we've seen that have been successful with microservices have done it as big bets. They've done a complete lift and shift from a monolith, and they've thrown hundreds of developers at the problem, and they're committed to taking risks and having downtime. If we don't have that, it behooves us to kind of see to it that commitment to quality is in place. So if you are struggling with Agile and DevOps, and you were thinking, let's go to microservices, think twice. There's a hierarchy of needs when it comes to your SDLC. You must create an infrastructure climate that is production ready. It is responsive, reliable, and automated first. That's a prerequisite to having microservices work for your company. Probably the biggest obstacle you're going to face is Conway's Law. Now, you may not know about this. This was a law created by someone back in the 60s. And I remember in a former company I worked for, we had basically we tried to break down our monolith and jump from AS400 based JDE processes to modern SAP for handling our retail backend. But the end result, I found out a few months later that we were hand entering orders into JDE behind the scenes. So SAP was accepting the orders, and then we were having to hand enter them into JDE. So what happened there? Well, Melvin Conway came up with a rule, and he said organizations which design systems are constrained to produce designs that are copies of those organizations. So basically the architecture of a system will be determined by the communication and organizational structures of a company. And I look back at my previous 20 years and I see that happening again and again. The way that we would write our application with the best possible intent would start to look like the company. If we were a monolithic organization, it would look like a monolith. If we were to sketch out Microsoft's organizational structure as a model, it would look remarkably like its products. And that's the same thing is true with Google and Amazon. So the very act of organizing a team means that certain design decisions have already been made. In a way, we're already kind of almost there. So we have to take this into account because if we're in a monolithic organization, we can start off on this great vision of instituting microservices. But if we don't have those small cross-functional teams, a dedication to quality, and kind of a healthy appetite for risk, we're going to end up instead creating a bunch of little monoliths. Our problem will get worse, not better. We see this kind of happening again and again in the field. So we have to kind of allow for that. and not try to jump ahead of the organizational capacity, the change capacity of our organization. As far as team sizing goes, and this is funny, they did a study of large primate groups, and 40% of their time was spent in grooming, just to kind of maintain group stability. So this is the way we are kind of in the coffee room at work. We're gossiping. There's some conversations. Maybe 40% of our time might be spent in kind of cross-group or inter-team communications, just to kind of keep the peace. So team sizes, when we see with microservices, try to avoid this, where we're keeping it from 5 to 12. Again, the smaller the size, like 5 people, that's a very high trust group. There's a low amount of conversation, a low amount of loss due to things like that. So small sizes are best. Again, the decision to move to microservices has to be company-wide. It doesn't work with just a portion of it. It doesn't work very well as pilots. We haven't seen that be very successful. And it requires a certain amount of desperation. Again, big bets. So we have to think to ourselves, could microservices actually make our siloing worse, where we have these little pockets of knowledge and all they know is one thing and they know it well, and there's no cross-group communication. There are fixes to this, but we do have to allow for it. The other question, this is me, about 5 in the morning, right? Much handsomer version of me, I guess. I'm working from home. I'm very distributed. That works very well with my team because we're fairly small. But again, I have people say, Dave, I love working from home. Is this going to work if we move to DevOps? Is this going to work if we move to a microservices type approach? And I will say very flatly, we see a lot more chances of success if the team is co-located and working in the same physical location. So perhaps my time of drinking coffee and walking around in my baby blue bathrobe, that might be over if I was working on a programming team for Visual Studio. So these are kind of the qualities we want to see in making up a team that you can plan for. So again, this is a drift boat. I love fishing. This is perfectly sized. You could build this in your garage, one person over maybe a couple months, just as a weekend project. Now imagine if you're trying to build, for instance, a battleship like this. Now these are both boats, right? But the level of complexity here is different. The battleship on the right required thousands of people, detailed plans, very complex governance. We're talking here about microservices. The level of complexity here is at a higher level. It requires a very high level of specialization. And we must plan for this. That's why we're saying this is a company-wide effort, because you only realize the benefits at scale. So think about what's in your plan then. If you want to adopt a microservices architecture, your standards and practices will need to adapt to this new pattern. You're going to need to organize teams in such a way that they can develop these end-to-end as distinct, independent products, not just a project, but a lifetime product. The development tests and production environments have to be bulletproof with this. And again, do you have the freedom to kind of shape your teams? I believe these 4 things right here are a prerequisite. You must have them in place for your microservices ecosystem, your architecture, to really work. So if you don't have these in place, it's okay. Just do a level set and maybe ramp up your maturity from a DevOps perspective before you make that extra leap to microservices. Please don't come away from this though thinking that I'm dissing microservices. I'm worried that you guys will come away thinking like I'm an old man on the porch yelling at the neighbors with my rascal scooter. Microservices, we know it's different from SOA because we already have several very awesome success stories with microservices. All I'm saying, I'm not trying to throw cold water in your face, is that it is only applicable in a subset of the problems out there. I reminded a friend of mine once said, just so you know, there's no such thing as a wrong answer. You've given me the right answer, but just to a different question. And I feel that way about microservices. Agile will help almost any company out there with any amount of development. DevOps will help most of them. Microservices may only apply to those companies that we know are risk-friendly. They have the ecosystem in place. the commitment to drive it through, and lots of skilled engineers. Those are kind of the components we see for success. So let's kind of walk through how we might implement. People are always asking, Dave, I'm committed to this. We want to make this happen. Our old application is creaky. It's killing our development firepower. We must change. Great. So let's talk about this with 2 sample roadmaps. First, though, let's mention some people look at their application as almost like a shame, and they say, well, it's grown out of control. I'm embarrassed we haven't fixed this before. It's okay. There's actually a very strong use case for a monolith-first strategy, because because by this point, after a year or 2 of development, you've mastered your domain. You kind of understand where the business boundaries lay and how you want the application to kind of be modularized to improve its changeability. You didn't know that on day 1. You may not have had the staffing to do it at day 1. So there's a reason why your application kind of grew that way. Now that you're at that kind of mid-state, it's okay for you to kind of leave your little hermit crab shell, and move to a bigger one. You haven't wasted as much time as you think. One of the things that we've seen is when you're starting from ground zero with a microservice, is you end up with a system that's so over-designed and over-engineered for future flexibility, it becomes impractical. It's definitely better to have an adaptable system. There's the old saying kind of holds true. You can fix something that's simple and broken, and you can fix something that's complex and difficult, but it's mostly working. But it's impossible to fix something that's complex and broken. So you haven't lost as much time as you think. And at this point with the application, you at least know kind of what you need to work on as far as your values. So start with the goal in mind. You don't want to just do DevOps for the sake of doing DevOps. Do you want to reduce the cost of coding, of connecting your services together? Okay, so then we might want to look at things like templated component stubs, standardized data passing formats, universal interfaces. Okay, well, maybe you have a different goal. What about increased release speed? Great. So then our values, what we're looking at to get out of this whole transformation, is a better deployment process. We're going to look at automated releases and having that be streamlined as much as possible. The other thing a quality might be looking for is improved resilience. Dave, our application must be highly available. Well, that's much more reasonable, isn't it?